If the roller coaster starts from rest at A and its speed increases at at equals 6 minus 0.06 s, and pay attention here that the tangential acceleration is not constant, so you cannot use the constant acceleration equations. Determine the magnitude of its acceleration when it reaches B, where SB equals 40 meters. Note here that SB is not x. SB is the curved distance from point A to point B. And you are given also the value of x, which is 30 meters, and y as a function of x, so you can find the value of y if required. Okay, so going back to the definitions, we can use v, which is ds over dt. We can use the definition of at, which is dv over dt. And we also need to use ads equals vdv because a is given as a function of s. In addition, since we're moving within a curve, we need the normal acceleration, and the question is asking for the magnitude of acceleration, which is the square root of at squared plus an squared. Finally, we need to find the value of rho from this relationship using y as a function of x. And since the roller coaster starts from rest at point A, we can assume our initial conditions, which are v equal to 0 at s equals to 0. So let's see what do we need to determine the magnitude of the acceleration at point B. We need the tangential acceleration and we need the normal acceleration. The tangential acceleration is straightforward. You just need to substitute s equals 40 in a of t and find its value. But an requires two things, v and rho. Rho can be found from this relationship using the curve. And now we need to find the velocity. And because of ads equals vdv and a is a function of s, we can find v from this right-hand side. So by applying, we have the definition of a of t. We integrate both sides and make sure that you have the correct s naught and the correct v naught, which are 0 in both cases. So we solve for the right-hand side, and we get that as a function of s, and then we substitute the value of s, which is 40 meters, and get the velocity at point B, which is 19.6 meters per second. So v is found. We need to find rho. From the curve, y is equal to x squared over 100. Take the first derivative, take the second derivative, and then use the first and second derivatives in the definition of rho. And you can see here that rho will be only a function of x, so we use x given in the figure, which is 30 meters, to find rho as 79.3 meters. So at is directly found from the relationship at s equals 40, and an now is equal to v squared over rho. We found v and rho, and the total acceleration, which is the magnitude, is found to be 6.03 meters per second square.